You know that feeling, right? You feel like you've finally cracked the code with an AI, but then it all falls apart just because you changed a single comma? Well, we're going to dive into the research that explains exactly why that happens, and more importantly, how we can actually fix it. This is all about AI's secret sensitivity to something as simple as punctuation. I mean, it's a feeling we've all had. You spend time crafting that perfect prompt, you get an amazing result, and you save it like gold. But then the next day, you use it again, but maybe you add an extra space by accident, or you forget to capitalize a word. And just like that, the magic's gone. It's a tiny, totally meaningless tweak that any human being wouldn't even blink at. And it sends the AI spiraling down a completely different rabbit hole. Look, if this has happened to you, you're not going crazy. This is a real, measurable problem, and thankfully, researchers are all over it. The researchers who really dug into this, Seleznyov and their team, they put it perfectly. They found that even tiny changes that have zero impact on the actual meaning of what you're asking can cause these wild swings in what the AI gives you back. And yeah, this whole thing has a name. It's called prompt sensitivity. It's this exact problem that makes building reliable, predictable systems on top of these models so incredibly challenging. So the billion-dollar question is, what do we do about it? How do we make these things more robust? All right, let's get to the good stuff. We're going to look at the key innovations that researchers have come up with to actually solve this problem. And some of them are pretty clever. So the solutions really fall into two main camps. On one side, you've got in-context learning, or ICL. Think of these as clever tricks you can use on the fly without having to actually retrain the model. And on the other side, there's supervised fine-tuning, or SFT. This is more like sending the model back to school to teach it how to be more resilient. So let's meet the main players. First up, we have something called batch calibration. You can think of this as a quick course correction. You give the AI a whole batch of prompts at once, and it kind of looks over all the answers together. If it sees a weird pattern, like it seems to be biased towards picking option A all the time, it just adjusts the probabilities on the fly to correct for that bias. It's like a real-time fact checker for the model's own habits. Next in the lineup is template ensembles. This is another one of those on-the-fly tricks, and it's basically the wisdom of the crowd approach. Instead of asking your question with just one prompt, you ask it in, say, 10 slightly different ways. Then you just average all the results together. The whole idea is that the weird quirks from any single prompt format get smoothed out by the group. And our final contender is LoRa with augmentations. Now, this one is different. It's a fine-tuning method. This is where you actually take the model back to school. You retrain a tiny part of it using a special dataset that is just jam-packed with different versions of the same questions, with all sorts of punctuation and spacing. You're literally teaching it, hey, all of these mean the same thing, so stop getting distracted by the formatting. Okay, so we've got our three main strategies. The researchers basically threw them all into an arena to see which one would come out on top. So round one is all about pure accuracy. And the winner is probably who you'd guess. LoRa, the fine-tuning method, just blows the others out of the water. And that makes perfect sense, right? It's the only one that actually gets to learn from the right answers during training. But as you're about to see, accuracy isn't the whole story. Not even close. Because here's the plot twist. When you measure robustness, which is just how stable the answers are when you mess with the prompt format, a totally different winner emerges. Batched calibration is the undisputed champion here. It dramatically reduces the model's sensitivity. And LoRa, for all its high accuracy, it didn't really do much to make the model less fragile. This is huge. It shows that a super accurate model can still be incredibly unstable. But it gets even more interesting. What happens when the world isn't so perfect? What if the data itself is a little messy? Well, the researchers decided to throw a major curveball to see what would happen. So in a perfect, clean, laboratory setting where your data is nicely balanced and every possible answer shows up an equal number of times, well, batch calibration is an absolute rock star. You can see it here performing beautifully. This is its home turf. But now, watch what happens when we throw that data out of balance. Let's say 90% of the right answers are suddenly option A. Boom. Batch calibration's performance completely tanks. The very thing that made it so great, its ability to correct for bias, becomes its Achilles heel when the data itself is genuinely biased. This is a critical weakness to be aware of. The study also turned up something really simple but incredibly powerful. How you ask the AI for its final answer matters a lot. If you let the model just generate the answer token by token, that's called greedy decoding, it's way less stable. But if you instead ask it to just rank the probabilities of the possible answers, it's much, much more robust.
It's a tiny change that can have a massive impact.
Now, I know what some of you might be thinking. Okay, this is probably a problem for smaller open source models, but the big dogs like GPT-4 must have this solved. Well, think again. The research shows that even the most powerful models out there are not immune. On some tasks, a simple change in formatting can cause their accuracy to plummet by a staggering 8 to 10 points. They're better for sure, but they are not perfect. So, what do you do when you're working with one of those big black box models through an API where you can't get under the hood? The answer is a really clever twist on that wisdom of the crowd idea. Instead of averaging probabilities, you just use a majority vote. You ask the same question 10 different ways, and you just pick the answer that shows up the most often. It turns out to be a super effective way to get stable results.
Okay, that was a lot to take in, so let's boil it all down. What does this actually mean for you when you're building with or using these models?
Here are the big takeaways. First, prompt sensitivity is real, and it affects every model out there, big and small. Second, batch calibration is a fantastic tool for making models more robust, but, and it's a huge but, it can fail spectacularly if your data isn't balanced. Third, fine-tuning with LoRa is your go-to for raw accuracy, but don't just assume it's also making your model more stable. And finally, remember that even the giants of the AI world can be tripped up by a single comma.
So this research gives us a really practical playbook. Number one, whenever you can, get the model to rank probabilities instead of just spitting out an answer. It's just more reliable. Number two, if you're working in a controlled environment and you know your data is balanced, batch calibration is a cheap and incredibly effective win. And number three, when you're calling a big model through an API, using that template ensemble with a majority vote is your best bet for getting stable, consistent results.
And that really leaves us with one final, much bigger question. All of this shows that just being smarter isn't the same thing as being reliable. As we keep building these incredibly powerful models, we have to ask, is the real challenge just making them more intelligent, or is it about making them more dependable? It really seems like the pursuit of stability is every bit as important as the pursuit of raw power.